Hello and welcome to the new style Edexcel GCSEs. These are the ones that go from grades 9 through to grade 1. This is paper 1 MA1/2H. It's the second paper in the higher tier. It is a calculator paper and we're picking up in question 21. In triangle RPQ, RP is 8.7 centimetres, PQ is 5.2 centimetres, and angle PRQ is equal to 32 degrees. Okay, so let's try to draw this. When we try to draw this, we realise that there's actually two possible triangles that we can make. And that's because this angle here doesn't help us decide whether we've got the smaller triangle or the bigger triangle. It's this angle here that would have fixed one or the other. And we're not given this length here, we're just given length PR is 8.7 and PQ is 5.2. So we've got two possible triangles, but if you look, this angle here in the smaller triangle is an obtuse angle, that is to say it's bigger than 90 degrees. And this angle here is an acute angle, so it's smaller than 90 degrees. And here in part A, we're told, assuming that angle PQR is an acute angle, calculate the area of triangle RPQ. Give your answer correct to three significant figures. So this is why we're told to assume that angle PQR is acute, because we're looking at the area of the bigger triangle. So we've got a big triangle here. We've got 8.7 centimetres, we've got 5.2 centimetres. If we knew this angle, we could use the formula that the area is a half of this length times the angle in between them, but we can't do that unless we can find this angle here. So the way to find this angle here is to find this angle here and then add this angle to this angle and then subtract the sum of those angles from 180 degrees. We can't find this angle directly because we don't know this angle and we don't know this length. So we know this length, we don't know this angle, but we know this angle and we know this length. So that just screams sine rule, doesn't it? So the ratio of the sine of this angle to this length is the same as the ratio of the sine of this angle to this length. In other words, sine q over 8.7, that's the sine of this angle over 8.7, is equal to sine 32 degrees over 5.2. And so if we move the 8.7 up here by multiplying both sides by 8.7, we get sine q is equal to 8.7 times sine 32 over 5.2. And now we know sine q. In order to get the angle, we just find the arc sine or the inverse sine. So this angle q here is equal to the arc sine of 8.7 times sine 32 over 5.2, which when we plug that into our calculator will come up with 62.4 degrees. So this angle here is 62.4 degrees. Then we just add these two angles together and subtract the total from 180 degrees, and that gives us our angle of 85.6 degrees. So now we've got this length, and this angle. We can easily find the area with the area equals a half AB sine C. We can't use half base times height. That only works on a right angled triangle. But the more general equation, area equals a half AB sine C, will work. So we've got a half times 8.7 times 5.2 times sine of 85.6 degrees, and if we plug that into our calculator, we'll get our area of 22.5 centimeters squared to three significant figures. So here's what the I know this looks quite a lot, but here's what the examiners want to see. You can draw a diagram. The diagram is optional, that they won't mark your diagram, so however you draw your diagram, however scruffy, they won't care, so long as you figure out to use the sine rule and you figure out that sine q over 8.7 is equal to sine 32 over 5.2. You do that, they will give you 1 mark for that. If you can get Q equals the arc sine of 8.7 times sine 32 over 5.2 is equal to 62.4 degrees, that is to say just multiply both sides by 8.7 and then find the inverse sine, that will also get you 1 mark. Now this part here, where you find the angle that's in the middle of the two measurements that they've given you, and then use area equals a half of one length times the other length times the sine of the angle in between, that will get you another mark, and correctly rounding it to 22.60 centimeters squared. Actually, even if you said 22.5 centimeters squared, that would also get you a mark. As you can tell, I've had to take a sneak peek at the marking guide to try and figure out what the examiners actually wanted. And the main reason I had to look at the marking guide was because of this question here, which kind of threw me. It said, if you did not know that angle PQR is an acute angle, what effect would this have on your calculation of the area of triangle RPQ? And my first response was, well, nothing, because I would have got this angle here, and then I would have used a half of this times this angle, and I would have got the area straight away. But what they want to test, what the examiners are looking for, is that you know that you can't use a half A times B times sine C on an obtuse angle. If this angle is greater than 90 degrees, you can't use a half A B sine C. I'll show you the reason for that if I pull up my calculator. I've actually gone ahead and calculated that this angle would be 117.6 degrees. So if I'd actually tried to do that, let's find the sine of 117.6 degrees, and I'm going to take the sine of that. Okay, so this is the sine. If I wanted to get back to the original one, if I take the arc sine to get back to the angle, and oh, the calculator said 62.4. That's because the calculator, not just the calculator, but the actual sine function will usually give you the arc sine function will give you the angles up to 90 degrees, between 0 and 90 degrees. It won't give you the angles that are over 90 degrees. So if you wanted to get back to the 117.6, what you would actually have to do is take that, you'd have to take 180 from that 62.4, and then we're back to our 117.6. So given that the sine of 117.6 is the same as the sine of 62.4, that's why we can't use a half AB sine C to get the area with an obtuse angle. So what they're looking for is for you to tell them that you can't use a half AB sine C if C is greater than 90 degrees. Therefore, you could bisect the obtuse angle, creating two congruent right angle triangles, and add the areas. They're looking for something like that. They're just looking for you to show them that you know you can't use the formula a half AB sine C if the angle is obtuse. Okay, I hope that was helpful, and I'll see you in the next video.